Hello, everybody. I'm Paul Beckwith, and this, of course, is my 3.5-year-old golden doodle, Newton. Well, he's got two names. I call him Newton, as my wife does, Susan. And my youngest, Edward, has called him Odin from day one. You know, Odin, the All-Father, of the Vikings, of the Northmen. And I've been doing a lot of research on the Vikings recently, reading a lot of books and watching the Netflix series on them, which are actually, I think, very well done. And maybe I'll have to start calling him Odin. Anyway, the last few videos I've been talking about the overall climate system and trying to put the collapse of the Antarctic sea ice into the picture with the corresponding reduction of the Antarctic overturning circulation, which I think is a very, very important and key factor. And I tried to put it in the context of the Atlantic Overturning Circulation, the AMOC, the Atlantic Meridional Overturning Circulation, shutdowns in the past, you know, what we know from the paleo record. What I didn't mention last video is there are also these other factors that come into play, especially the methane question, right? It seems that people don't talk about methane too much. I'll have to do some separate videos on the methane sinkholes in Siberia, the methane on the eastern Siberian Arctic shelf, that sort of thing, because that's still a wild card. And of course, if there's any shift in climate, you know, then those things can enter into play, of course. Now, it's interesting because just yesterday I was going to post another video on this paper that just was published on the 24th, so just 3 or 4 days ago, in the Journal of Geophysical Research. It's open access. It's called Physics-Based Indicators for the Onset of an AMOC Collapse Under Climate Change. So they try to look at, you know, what physical parameters can we measure to know if an AMOC collapse is about to happen. I think Newton wants to get down, and he's also getting extremely heavy. So I should have actually brought him on my archaeological dig, but he would have been tugging me off the rock when I was filming that last video. And but you know, he could have made some great discoveries there at the archaeological site. He would have gone off into the woods, and you know, he may have come back with a stick, or maybe even with a, you know, bone, if he found some sort of you know, graveyard site near the surface. I could see Newton coming back with an ulna bone, or, you know, a human leg bone or something. Although the National Capital Commission says that there's no grave site that they're aware of on that land where I was filming the video, and they found the arrowheads from 6,000 years ago. But it doesn't mean that they're not there. And I could just imagine Newton coming back with an arm bone, and they could date it to 5,000 years ago, you know, and he'd be on the front of the local newspapers as, you know, the Newton, the bone hunter, archaeologist or something. Anyway, just a thought, just some crazy thoughts. So it's probably better that I didn't bring him. I didn't know if he'd be allowed near the archaeological dig site. So this paper, this paper that came out 3 or 4 days ago, it's interesting because it was looking at the ocean currents, the downwelling currents. It's looking at many parameters in the ocean. There's a fixed mooring at 26.5 degrees north where they measure the overturning, the ocean currents, temperature, salinities, water density, all kinds of parameters from these instrumentation that's moored to the ocean floor. And they also look at the data from 34 degrees south in the southern hemisphere. Surprisingly enough, they find that some of the buoyancy parameters that change at 34 degrees south can actually be a better indicator for when the AMOC in the northern hemisphere is going to shut off. And they got some very disturbing signs and showed that under medium emission scenarios to high ones, that the shift could happen within a few decades, and that could put the AMOC on a course to basically shutting down. So I then came across today, I'm glad I waited on this paper, which is right here, and I'll talk about this in detail. But first I want to talk about the article that came out in The Guardian just tonight called "Collapse of Critical Atlantic Current is No Longer Low Likelihood." So I assumed, of course, when I read that title, that this is now an article on the paper, which was published 4 days ago, but no, it's not. So I investigated further, and it's based on this paper, which was just published basically today online. Shutdown of Northern Atlantic overturning after 2100 following deep mixing collapse in the projections. So, and Stefan Ramsdorf is on here. So this paper is also open source, so I had a quick look at it. So this paper was actually scooped by this paper, but they do refer in the Guardian article to, it's mostly about this paper with Ramsdorf, because Ramsdorf, I don't know about the other authors, but he's got the huge connections with global media, especially with people at The Guardian who publish these excellent articles on climate. So that's interesting. And what they're showing is that the AMOC, they look at the mixing layers and densities and stuff, and I'll talk about this paper in detail. They talk about some of the effects and timescales on when the AMOC is likely to collapse, and they're also saying that it's a lot worse than the IPCC in the last assessment report. It's no longer a low probability event, and interestingly, they don't consider additional water coming off Greenland in their analysis, and they also don't consider, I don't see any mention of Antarctica sea ice and the Antarctic meridional overturning circulation significantly declining, but that's just happening since 2015. For the last 10 years or so, dropped off a cliff, the sea ice around Antarctica, and the paper which I talked about is this paper, The Emerging Evidence of Abrupt Changes, and this is what I talked about in great detail 2 videos ago, and then also discussed again in my last video when I was at the archaeological dig site. Okay, so this isn't considered. This makes the pictures I'm about to tell you about the AMOC even worse, in my opinion, even more likely to shut down, because it's all connected together in the climate system. So let's see what the article says. Well, first of all, the Guardian article. Okay, collapse of critical Atlantic currents, no longer low likelihood. Scientists say shocking discovery shows rapid cuts in carbon emissions are needed to avoid catastrophic fallout. Well, we all know that we're never going to see rapid cuts in carbon emissions. We're going to reach the catastrophic consequences of just ignoring climate change and having society run by fossil fuel companies and governments, and just keep ramping things up, and let the chips fall where they may. And so I'm trying to tell you where the chips are going to fall. I've no hope that fossil fuel emissions will be cut. I've no hope there'll be rapid cuts of carbon emissions. We're just going to head out and see the consequences of these things. Probably many of you are feeling the same way at this point. So the collapse of the critical Atlantic current, the AMOC, it can no longer be considered a low likelihood event. And the IPCC assessment reports, they talk about low likelihood being less than 10% chance of collapse by up until 2100. So the AMOC, it's a major part, of course, of the global climate system. It brings the sun-warmed tropical water to Europe and the Arctic, where it cools and sinks to form a deep return current. The AMOC was already known to be at its weakest in 1600 years as a result of the climate crisis. So as we go through here, I may as well show you the links as they come up. So the weakest in 1600 years, let's just have a quick look at that. That's a Guardian article from more than 7 years ago. Gulf Stream current, all the links will be in my description of the video. Gulf Stream current at its weakest in 1600 years. Okay, so there was a paper here. They talked about if it did collapse, okay, it would be a catastrophe for society. So Western Europe would see far more extreme winters. Sea levels would rise fast on the eastern seaboard of the U.S., up to 70 centimeters or 2 feet on the eastern seaboard of the U.S. That would we'd get a disruption of the tropical rains, the intertropical convergence zone rains, big, huge effects in the tropics and the equator. So the new research from 7 years ago showed that the AMOC was 15% weaker than it was in 400 AD. Okay, it said that, it talks a bit about, some of the reasons for the weakening: melting ice in the Arctic, particularly from Greenland, less fresher, less dense water, weakening the downwelling. The AMOC slowed since 2004, but it goes back, there's ocean-based evidence that it's the weakening is unprecedented in 1600 years. And this is a good example. It shows the Gulf Stream coming up here, bringing warm water across to Western Europe, the oceans off the North Atlantic, and then the cold water descending in this loop. So it's a huge part of the Earth system. It's very important. During the last ice age, there were some big changes in the AMOC, led to winter temperatures changing by 5 to 10 Celsius in as short a time as 1 to 3 years. Okay, Greenland temperatures changed 15 degrees Celsius in less than a decade. So these things can happen very quickly, very abruptly, as I talked about. They're really tipping points. So what they did to get this 1600-year number, they did the study off Cape Hatteras of North Carolina. They looked at ocean core sediments. Larger grains of sediment meant that the AMOC was faster. Because it was faster, it could carry larger grains of sediment. When it slowed down, it could only carry the smaller grains. So they looked at grain sizes in the sediments to get a proxy or a measure on the AMOC currents. They also used the shells of tiny marine creatures to get the idea of the temperatures. And then there was another study that looked at data, another nature study. It looked at data from in the last 120 years. So the AMOC today, that was 7 years ago, 15% weaker than 1600 years ago. Okay, so that was that article. So I'm going to go through these articles as they come up, as these links come up. So going back to the main article, right, this one, the collapse is no longer low likelihood. Climate models recently indicated that a collapse before 2100 was unlikely, okay? But in this analysis, they didn't run the models for as long as they did in this particular thing. And also they found that there's a lag. So the new research shows that the conditions could tip in the North Atlantic, and then that would make the AMOC shutdown inevitable, but it might not happen until 50 or 100 years later, after the warning signs were tipped. And that's what they found with this new study. I'm just going to show you the link to this particular study right here. It said that total collapse of vital Atlantic currents unlikely this century, right? And they talked about how they came to that sort of thing, but it was only using 20 years of direct measurement. So there's large uncertainty. And right, they saw, and they also said that, even a weakening, not actually a tipping or a shutoff, would have huge impacts on the climate. So it doesn't really matter if we have a strong weakening, say 80%, or a collapse. Basically, the results would end up being the same. Okay, and they talked about the huge melting from Greenland ice cap and the 1600 year being the weakest, and warning signs of a tipping point and so on. Okay, they say we have to avoid a collapse at all costs. Okay, so going back, so what their new research found is that if carbon emissions continued to rise, and of course, you know, who thinks that they're not going to continue to rise, right? I mean, we have to be real here. 70% of the model runs lead to a collapse, a complete shutdown of the AMOC. The difference is in how long that takes. Intermediate level of emissions, we're much higher than that. We're at the high-end carbon emissions now. Even intermediate level emissions are, the collapse occurred in 37% of the models to a shut-off AMOC. Even with low future emissions, if we get our act together and really lower emissions, the AMOC shutdown probability is still 25%, which is much higher than the 10% number, the low likelihood probability in the IPCC models and Assessment Report 6. Scientists have warned previously that AMOC collapse must be avoided at all costs, and I think there was another Guardian article on that. This was a 7-year-old one again, avoid Gulf Stream disruption at all costs, scientists warn. And they talk about some of the things, they talk about some of the past collapses, some have caused some of the most extreme impacts in climate history, a significantly weakened system. Even if it doesn't collapse, just weakens a lot more. It's more severe storms in Europe, faster sea level rise on the east coast of the U.S., increasing drought in the Sahel. And I've mentioned all of those things. This would be because of the ITCC, the ITC Intertropical Convergence Zone, ITCZ, shifting southward. Huge impact and tipping points. And they talk about the AMOC actually weakened 15% since 1950, thanks to melting Greenland ice. This is a massive slowdown, equivalent to halting all the world's rivers 3 times over, or stopping the greatest river, the Amazon, 15 times. And we haven't seen this weakening in 1600 years. That number comes up again. Okay, during the last ice age, winter temperatures changed by up to 10 Celsius within 3 years in some places. And they talk about some of the quotes from Stefan Ramsdorf from the study of past climate. We know changes in the AMOC have been some of the most abrupt and impactful events in the history of the climate. And it looks like we're heading there as well. The system's highly nonlinear. It's basically, we'd wreak havoc to deep sea ecosystems, much less oxygen going to the deep sea. As I mentioned in my last video, much fewer nutrients going to the surface, complete collapse of ecosystems in the oceans. Other research showed that Greenland's massive ice caps melting at the fastest rate in about 450 years. Remember, this article was from 7 years ago, okay? So we have to avoid this at all costs, and we're not doing that. We're heading right to a collapse. Okay, the tropical rainfall belt shifting, that would affect millions of people relying on it to grow their food, plunge Western Europe into cold winters and summer droughts, add 50 centimeters to sea level rise in a very short period of time, 70 centimeters on the east coast of the U.S., in the time it took to collapse the AMOC. So, I don't know, very, very fast. And they show here, this is the Gulf Stream coming up, and then the water cools down, it's going northward, it gets saltier because the melting ice rejects salt. This is very salty water coming off the melting ice, and sea ice formation rejects salt, so that makes the water very dense. It goes to the ocean floor, okay, and is carried south. So Ramsdorf himself says, and I quote him a lot because he's a big shot, go-to guy by mainstream media. And interestingly enough, this article is only coming out after Ramsdorf's paper came out on the 28th. It didn't come out when the previous paper came out on the 24th because those people don't have connections with mainstream media, like they don't have the name recognition that somebody like Ramsdorf has. I've met him. He's a neat guy. We've had a chat on at least one occasion, I think a couple occasions. The new results are quite shocking, according to Ramsdorff, because I used to say that the chance of AMOC collapsing as a result of global warming was less than 10%, right? That's the number in the assessment report. Now, even in a low-emission scenario, sticking to the Paris Agreement, it looks like it may be more than 25%, right? So 25% chance of it shutting off with low-emission scenario, 37% shutting off in a intermediate emission scenario, and greater than 70% chance of it shutting off completely in a high emission scenario. So these numbers are not very certain, but we're talking about a matter of risk assessment where even a 10% chance of an AMOC collapse would be far too high. We found that the tipping point where the shutdown becomes inevitable is probably in the next 10 or 20 years or so. That's a shocking finding. We have to act really fast to cut emissions. And of course, we're not going to do that, right? We're going to not cut emissions and we're going to see what happens. That's my prediction anyway. Prove me wrong, world. Scientists spotted warning signs of a tipping point in 2021. So let's have a look at that article right here. Okay. 4 years old, 2021, climate crisis, scientists spot warning signs of Gulf Stream collapse. I think they were talking, this is probably the global warming hole south of Greenland and the reduction of the currents in the ocean buoys. They mentioned the 1600-year thing again. They talk about the effects on endangering well, this says it would, it talks about more storms, lowering temperatures in Europe, pushing up sea level, but it also endangerment of the Amazon rainforest and the Antarctic ice sheet. So it actually mentions Antarctic ice sheets. This is the only article that does that, of these articles I've shown you so far. So, parts of the Greenland ice sheet are on the brink. The world may have already crossed a series of tipping points. According to a 2019 analysis, it looks like I've talked about the collapse of the sea ice in Antarctica, that tipping point from 2015 onwards. And, global heating is indeed increasing instability of the currents, according to 8 independently measured data sets of temperature and salinity going back 150 years. So they talk about, there's the analogy of the chair. You push a chair, you can alter its position. It doesn't affect the stability if all 4 legs remain on the floor. But if you tilt the chair, you affect the position and stability. Reminds me of my 3-legged bar stool. They talk about a 4-legged chair. Tipping, okay? So there's this article. So going back here, yes, there's warning signs. I think one of the most impressive warning signs and obvious ones is the cold blob south of Greenland. Even in some intermediate and low emission scenarios, the AMOC slows drastically, completely shuts off. So the shutdown risk is much more serious than people realize. Now they talk about 2 studies here. Okay, they talk about this study published by the journal Environmental Research Letters, and this is a link to this study here, okay, which I have the paper, it's open source here, and the other, they do actually mention, as we continue down the article, they do mention the first study that I showed you that was published about 4 days prior to this one. It scooped these guys. But these guys get the Guardian article. So in this new Ramsdorff co-authored publication that came out just today, scientists found that in many models, the tipping points reached in the next decade or two. The shutdown of the AMOC becomes inevitable due to a self-amplifying feedback. Okay, so air temperatures are rising rapidly in the Arctic because of the climate crisis and Arctic temperature amplification. The ocean cools more slowly there, warmer water is less dense, therefore sinks into the depths more slowly. When the sea ice forms, it rejects salt, which makes the water heavier, so that's counteracted by the warming. There's more rainfall, more fresh water accumulating in the surface waters. The salty surface water is diluted, it's less dense, so it slows the sinking. Now it says another new study using a different approach, and that's a link to the study I first showed you that came out 4 days ago. Okay, so we will talk about those results. I'm trying to give you the whole sort of overview of it. My dog is having a nightmare, so I have to kind of nudge his leg so he wakes up a bit and stops his nightmare. It's okay, doggy. Yeah, it's a good boy. Good boy. Okay, they say that this other study, using a different approach, found the tipping point's probably going to be reached around the middle of this century. I told you it looks at some physical parameters. In fact, the buoyancy at 40 degrees south in a network of ocean buoys and stuff, when that changes sign and then that can be very, very bad precursor for a shutoff of the AMOC in decades to follow. So anyway, they ran all these models in this new paper, and they got these numbers of 70% chance of the AMOC shutting off with the high emissions, 37% with intermediate emissions, and 25% with low emissions. Compare that to the 10% figure, which was mainstream science up until this paper, up until this new result. So we no longer have a low likelihood, high impact event. With an AMOC shutdown, we have a high likelihood, high impact event. Okay, so it's no longer low likelihood. You can't say it's low likelihood with these sort of percentages. Okay, so this is very significant. Now, it could even be worse because the new models don't include the torrent of meltwater from the Greenland ice cap that's freshening the ocean water. Well, how can you not account for that? So that refers to this article, just over a year old. Greenland losing 30 million tons of ice an hour. That's 20% higher than previously thought. May have implications for collapse of globally important North Atlantic ocean currents. May have. Well, okay, yeah, of course. That's so this additional source of fresh water pouring into the North Atlantic, it's leading to a much higher risk of collapse, obviously, of the ocean currents called the AMOC, right? Which of course has the severe effects on humanity. And they talked about the Greenland's lost 1 trillion tons of ice since 1985 from glacier retreat alone. That's quite a bit of ice, 1 trillion tons of ice. That's a hugely large amount of ice. And you can see this is ubiquitous acceleration in Greenland ice sheet calving from 1985 to 2022. So look at the increase. What is it? What's the scale here? Number of calving events, mass of Greenland ice sheet. This is a mass in billions of tons. So 1,000 billion tons is 1 trillion tons. So 1 trillion tons of ice lost since look at 1 trillion tons of ice lost, since 1985, right? And you can see a huge precipitous drop here, and then, so a slope here, and a slope here with a turning point around 2000 or so in Greenland ice loss acceleration. And if you dump fresh water on the North Atlantic, you get a weakening of the AMOC. I discussed that in great detail in my last video while I was sitting at the Archaeological dig on the Ottawa River over on Quebec side, just across from the Ottawa, Ontario, and the Parliament buildings and a beautiful waterfall. At the Archaeological dig, and I explained how that was underwater before, and people have been telling me it wasn't the Agassiz Sea over Ottawa, it was the Champlain Sea, and I think the Champlain Sea was actually, it was the more local name. It was connected, I think, to the overall Agassiz, or maybe the Agassiz drained out first, and then more melt created the Champlain Sea, over Ottawa, and then that collapsed and gave way. Anyway, I have to look into that. So they looked at, for the Greenland, they looked at AI to map 235,000 glaciers, end positions at a resolution of 120 meters, and they basically added 30 million tons an hour on average to Greenland melt. And Lenton, the tipping point guy, said that he talked about tipping points in various systems in the climate system and so on. So this is not good. And then, you know, they looked at the Antarctic ice shelves, and the total loss has doubled to about 12 trillion tons when, you know, when you account for shrinking area of the ice shelves and thinning of the ice shelves and so on. So, you know, we're really poking a beast here. We're poking a saber-toothed tiger, and it's going to come and eat us all soon. So there you go. Okay, so these results are important. So the you know, we're the ocean's changing significantly. We're shifting things in the North Atlantic. We're shifting things around Antarctica. We're basically playing with fire. The loss of sea ice and the resulting slowdown of the Antarctic overturning circulation. Don't forget that part of the thing that keeps the thing going is a whole system, right? So if you you know, there's push and pull in the system. And if you just shut it off, if you chop it off at one section, you can chop off the whole thing, right? And then when different sections close down and reduce flow, that then feeds back and affects other systems. There is a time lag involved in it. Okay, so I think I've covered most of those things. Keep in mind keep in mind methane effects. So this is the paper here from Ransdorf, and this is the paper from a couple of days ago. I'm going to talk about this paper first because it actually came out 4 days before the Ransdorf paper. So I'll just talk about the abstract basically. So this is a complex modeling paper. It's open source. You can look at all of the details. I'm just going to talk about the abstract and show you a couple images. The AMOC, the Atlantic Meridional Overturning Circulation, important tipping element in the climate system. Large uncertainty whether it will start to collapse with climate change, needs long climate model simulations, they're not always available. So they looked at the community Earth System Model, CESM. They wanted to develop a physics-based indicator for the onset of an AMOC tipping event. This indicator is diagnosed from the surface buoyancy fluxes. So fluxes, movement of water over the North Atlantic, the surface buoyancy, so the density of the water, which depends, of course, on the amount of salt content and the temperature. So more salt, the water's heavier. Colder temperatures, the water is heavier. It's more dense. Okay, so they looked at freshwater forcing, freshwater hosing, freshwater pulse forcing, climate change scenarios and different climate models. They looked at 25 different climate models, and that shows that the AMOC could begin to collapse by 2063. The spread was from 2026 to 2029. So there's a lot of variability, a lot of error. The mean is 2063, but it already includes as of next year. Under an intermediate emission scenario, or by 2055, with the spread from 2023, a couple of years ago, to 2076, under a high-end emission scenario. And when it collapses, the northwestern European climate changes drastically, huge. It says it will likely induce severe societal impacts. There's always these fudge words, will likely, right? They're all stuck in. Anyway, so multiple AMOC collapses are simulated. A physics-based indicator derived from surface buoyancy fluxes. And so they actually, you know, they give some background and different observations of the AMOC, some details. There's lots of models and lots of data, graphs put in, stuff like that, showing AMOC strength at 26 north and the density, surface forcing, buoyancy, stuff like that. Bunch of equations, more figures. You know, as you go down, they then start talking about the freshwater forcing at the surface. The Sverdrup is the flow rate. Then they talk about buoyancy fluxes due to salinity component and temperature component, right? So higher salinity, denser water, lower temperature, denser water. So the effects of buoyancy, a bunch of buoyancy graphs over time through the different months and how it's changing in the computer models. And they found, actually, it's interesting, but they found that so I go back, if I go down to kind of it's a very involved paper, very detailed summary and discussion. They found that in modern AMOC theory, adiabatic AMOC outcropping isopycnals are lines of constant density. So they looked at the density of the water, different latitude bands from this is the flux or the water flow rate of North Atlantic deep water this term. And it's an indicator for the onset of a tipping event, but it's hard to get that. So then they looked at buoyancy fluxes, and they found that buoyancy, you can easily get buoyancy from the models. And they found that actually it was interesting, they found that the buoyancy in the southern hemisphere at 40 degrees south is a good monitor of when the AMOC in the northern hemisphere is going to tip. Okay, so there's lots of details in this. And you can look at the paper. Maybe I've hacked it up. Maybe I need to discuss it in more detail in a separate video. But I want to talk about this paper now. So this is the one that Ramsdorf is involved in. He's at the Potsdam Institute in Germany. And when he publishes a paper, it makes world news. He's got the connections with the media track him. I told you before, there's certain people that they go to, that whenever they do anything, they can go and sit on a toilet and make a lot of noise, and the media, reports on what they do, because these are go-to people, right? Him and Michael Mann, and there's a few other, there's 3 or 4 others. James Hansen's not one of them. He should be. Okay, so anyway, the abstract of this paper. Several more recent global warming projections in the coupled model intercomparison project 6. So that's CMIP 6, the latest version of all the computer models. They extend the modeling beyond year 2100 to 23 and 2500, and they show that there's transitions in the AMOC to very weak overturning below the surface mix layer, so less than 6 Sverdrup of flow. 1 Sverdrup is 10 to the 6 cubic meters per second. It's a volume flow rate equivalent to about all the flow rate of the rivers in the world. In the high emission scenario, things flipped. They looked at intermediate and low emissions. They found that the weak, when the AMOC shuts off, the weak overturning states have a shallow maximum overturning at depths less than 200 meters. So instead of going to the deep ocean floor, the water goes down, like it doesn't go down. It's in the top, stays in the top 200 meter layer. There's a shutdown of circulation. It's the North Atlantic deep water formation. Northward Atlantic heat transport at 26 north. It decreases to about 20 to 40% of the current value. So there's much less heat being carried up to the northern hemisphere. Heat release to the atmosphere north of 45 degrees north weakens to less than 20% of its present-day value, and in some models completely vanishes. So we get strong cooling in the subpolar North Atlantic, Northwest Europe, England, Northeast Canada, the Scandinavian countries, like they get nailed. Basically, I mentioned in the last video, the UK would lose at least 3/4 of its arable land for growing crops. The Scandinavian countries couldn't grow food, and so they're going to have to start becoming Vikings again, and finding land and to grow food elsewhere. Maybe start a new category of Viking era 2.0. And it's interesting because if you do look at the Columbia University climate risk assessment on countries, they say that Norwegian and Sweden and Denmark are in the top 10 places to withstand climate change into the future. Of course, they don't account for an AMOC shutdown when they come up with their numbers. In all cases, the transitions to a weak and shallow AMOC are preceded by a mid-21st century collapse of maximum mixed layer depth. So this mid-21st century, so within 20, 25 years, the maximum mixed layer depth. That's their indication showing, and this is in Labrador, Irminger, and Nordic Seas. These are areas where there's downwelling and where the meridional overturning circulation has the vertical dropping of the water to the ocean floor. The convective collapse is mainly caused by surface freshening from a decrease in northward salt advection due to the weakening AMOC, but is likely initiated by surface warming. And also, they don't talk about the water hosing from Greenland. Of course, that's a big factor too. There's maximum mixed layer depths in the observations are dominated by internal variability, but notably featured downward trends over the last 5 to 10 years in all deep mixing regions. Okay, so it's becoming more and more variable, and that often happens before things shut off. Okay, so let's just have a look at some of the, they talk about some of the things I've discussed in the last video. So the AMOC transports warm upper ocean water to the north, where it sinks and returns as cold deep water to the South Atlantic. So changes in AMOC or slowdowns and shutoffs, it strongly impacts the northward ocean heat transport. It monkeys with the way heat is transported on the planet. It changes the climate of the Atlantic mid and high latitudes. The amount of carbon going to the ocean floor is greatly reduced, so levels in the atmosphere skyrocket because over half of the carbon we emit is absorbed in the ocean and ends up going down in the deep ocean after acidifying the surface layers. So instead of 3.5 ppm rise per year, you can look at maybe 7 ppm, maybe 7 to 10, I don't know. The less oxygen goes to the ocean floor, right? The oxygen uptake by the ocean decreases, less goes to the ocean floor, so you get lack of oxygen at the ocean floor, huge die-off of marine creatures, benthic creatures that live there. The nutrients are upwelling. It's not mentioned here. You get much fewer nutrients coming up from the deep ocean floor to the surface, so it die-off of marine life on the surface. Sea level in the northern North Atlantic greatly increases. The tropical rain belts shift. And, in 1961, it was demonstrated that a simple theoretical model of the thermohaline, high temperature and salinity-driven circulation, possesses two modes of operation, and you can have abrupt transitions between the two. They called it a saddle node bifurcation. Of course, that's really a tipping point. And we're seeing that happening. And paleoclimate evidence is showing that we've had these major abrupt climate changes during the last glacial period. And I talked about the Younger Dryas shifts and also the 8.2K event in my last video as well. Okay, so we're talking about global repercussions. They said that the IPCC report said the AMOC collapsed before 2100, unlikely, less than 10% probability. Right? But the numbers coming from this paper are much higher. I told you 25% for low emissions, 37% for intermediate emissions, and 70% for high emissions. And this the conditions could be set up for these things to happen in the next few decades. It could be set up. It would still there'd be a lag between the actual shutdown and the conditions being set up to do this. Okay, so they talk about, so there's lots of data here on different models and stuff. This is a time frame. We're about right here, 2025. Slowdown, you can see, how this thing can continue, and it can take a long time in these models to shut down. But these models don't include the water hosing coming from Greenland melt, and they don't include the pulling effects from the Antarctic overturning circulation slowdown, and that's just been going on since 2015 with the collapse of sea ice around Antarctica. Okay, and then there's different depths of overturning maximum showing, that this is actually a shallowing. So the overturnings, the water's not overturning, going to deeper levels in the areas that were being looked at. There's different areas here showing water flow rates and stuff. But I want to show you, a lot of these spaghetti plots of things. This is the region. So they talk about the Labrador Sea here. This is the Irminger Sea in this region, and this is the Nordic Seas, and this is where water descends to the ocean floor, and to get the thermohaline overturning going. And they looked and they show that the mixed layer depths of the water descending into these regions can greatly shut off. So this is showing, this is 2025. By 2050, you can get a huge drop in, this is shallowing water, deeper water. Shallowing, it's kind of reversed, which is a bit confusing, but they show this curve here, by about 2050 with some of these curves, you're down to a couple hundred meters of mixed layer depth, indicating that there's going to be a massive shutdown of the AMOC. Okay, and this is, so there's different models here and stuff. So this is real stuff here. There's some more modeling from the different regions, different scenarios set up. Okay, mixed layer depths and size, the geometry, the sizes, the extent of it, stuff like that. All right, a lot of different things looked at. Role of surface buoyancy, more things, surface layer salinities and temperatures and how, those things. And you can see the trends of these curves and when things shift. Just look for the rapid changes, and you can see some of them are, this is 2000 to 2100, so rapid shifts, right? In all of these parameters in different models and so on. Surface buoyancy, again, many changes happening, within this time period. So, basically, they've shown that we're reaching a tipping point. It'll push the northern AMOC into a terminal decline. Doesn't sound good. From which it will take centuries to recover, if at all. Doesn't sound good. Okay, and they talk about thresholds for what they call a tipping and so on, projections, more squiggly diagrams and stuff. Anyway, you get the message, right? You get the message. The percentages are much higher than have been indicated in any previous mainstream reports, and this is a mainstream paper because Stefan Ramsdorf's on it. Many other people are writing papers. I talked about these guys in the paper that was done 4 days earlier. Anyway, I think you got the point. I think I've made I've got across most of the points. It's complex. I mean, I hope I haven't massacred these papers. I apologize to the authors if I have. Newton, this stuff is giving Newton nightmares. He's starting to, you can hear him in the background having his bad doggy dreams. So it's okay, doggy. It's okay. Yeah, so I just have to, he's good. He's good. And his leg twitches and stuff. This stuff is, sorry, Newton. I don't mean to be giving you nightmares. Anyway, I have to start talking about some other topics. I was going to do that. I wanted to talk about some effects on the jet streams and other things. I'll get to those things very, very soon. Anyway, thank you for listening. Please go to my website, paulbeckwith.net, and donate to PayPal to support my research and videos. Or you could go to Patreon. Just find me on Patreon, set up something there. I want to keep my videos and all my work open to the public, so I don't want to stick it behind paywalls. So please set up something, equivalent of a coffee a month or something like that, and that'll keep me in business. And I'm hoping to go to the Brazil Climate Conference in November, so just awaiting whether badges are available and if I can get accommodation. I may have to bring a tent and sleep in the Amazon, with a hazmat suit so the mosquitoes can't get me. There's yellow fever in that region right now. And accommodation costs you 2 arms and 3 legs. Very, very expensive at the moment. Anyway, I'll, until next time. So until, we'll be back in a day or two, I think, with more videos, more topics, more stuff. So again, please consider donating to support my work to keep me solvent. Thanks for listening, and bye for now.